together. Okay, 5-5. Back in chapter 4, we used the binomial distribution. Remember the binomial PDF and the binomial CDF?
No.
For the little function on the calculator that gave us all the probabilities if it was a binomial situation, success and failure? What we're going to do today is we are going to approximate the binomial distribution using the normal distribution. Why we do the same thing two ways, sometimes I question why. So, let's quickly review the binomial situation. A binomial situation, when you did a trial, you had two outcomes. You either succeeded or you failed. So that was the success and failure distribution. Success or failure. Do you remember what n represented in that situation? Yep, the number of trials you were doing. P represented the probability of success. Q was probability of failure. And X represented, yes, the number of successes. Good job, Austin.
Thank you.
And if we do have to do one with the binomial distribution, we're going to use the binom PDF and binom CDF. So we'll quickly review what you put into those programs. The binom PDF, you would feed this the number of trials, the probability of success, and then X, the number of successes. And it would give you that one probability. If you use the binom CDF and you fed it N, P, and X, what did CDF do for you?
Added them all together.
Starting from 0. So this one added probabilities together from X equals 0 to the X number that you put in the program. Okay. So, that's all we did in chapter 4. And you might have a problem or two that pop up and you get to do that again. Today, when can we use the normal distribution to approximate the binomial? There's a little check. So, to see if the normal distribution can be used you have to make sure your sample size is big enough. Okay, and it's not the magic number 30 here.
Oh.
Yeah, it would be nice if it was the magic number 30, but it's not. Your number of trials times your probability of success has to be greater than or equal to 5. And the number of trials times the probability of failure also has to be greater than or equal to 5. This is just a check to see if we can do the normal instead of the binomial. I don't know, because I wanted and between them, and if I do it vertically, people don't see it as well.
Is it gonna be a 3?
Nope. Two things have to happen.
You numbered them like it was going to be a list.
I did, and that's normally the way I do it, but people don't, they just check one, they don't check the other, and they miss it. But if I write it horizontally, I'm like, oh, God, they checked both of them.
I don't know why I just got stressed out over
I don't know.
it.
Just amazing the way if you write something this way versus this way, it works, it doesn't work. I don't know, a little teaching tool, I guess. Two things have to happen. Okay. If it works, then we can do the normal distribution stuff like we've been doing, and like yesterday. And yesterday, you need to know two things to do the whole probability business. You need to know the mean, and you need to know the standard deviation. So, if these both come out, then 1 and 2 happen, then the mean of your distribution
I just don't understand. So
What? Why did you stop writing?
well, because I'm going to make the graph instead of words.
Jeez. Can you do both?
If you want to,
Okay.
then the mean will equal,
I don't even know where I'm supposed to write.
just like me, be just like me, n times p.
I refuse.
That's how you're going to get your mean. It's not going to tell you the mean of the distribution. We can calculate it with n times p. And the standard deviation of the distribution will be the square root of npq.
Okay, can you say that slowly in words?
Yep.
Okay.
Why did we need to draw that?
Then the mean, that's all I got.
The mean equals n times p.
Are you putting anything else in the...
Nope.
Why did you draw it?
And the standard deviation
No.
equals the square root of npq. Because when we do probabilities, we always have to come back to this graph.
Oh, crap.
What does this do?
It's going to help us find probabilities. Eventually.
I don't know how to find it.
Yep, this is different. You're going to see. It's. I said it's marrying two things together.
Is it easier now?
It's no different. How's that? Except the difference is, all the other problems we had, they told you what the mean and standard deviation were. Agree with that? They say the mean is this, standard deviation is this.
Yeah.
Not going to tell you that this time. You're going to have to find the mean and standard deviation with these two little formulas. That's the only difference. So then do we still turn our x value into a z-score and then do we still go into NCDF?
Yes.
Yes. So the extra step is going to be, they didn't tell me the mean and the standard deviation, so I got to do these two little plug and plug formulas. That's how much harder it is today. Well, except for one little catch that's coming right now. Of course. Couldn't quite be too easy.
I'm gonna boycott.
Okay. When we put it all together, you'll be okay. So don't panic. Don't hit the panic button. Keep your hand off the panic button. Don't press it. Okay, there we go. All right. What we've got to also have to do is called, and this is once you get by this, you're going to be okay. Correction for continuity. This is the part I kind of wanted to just do yesterday. That would have probably taken more time than I thought.
This is the whole new...
Yep. Whole new idea. Continuity. Correction for continuity we do to include all possible x values.
Are you doing this on purpose?
I don't know why I'm bothering you guys today. It's not my intention.
Go back.
You can type N, you can write it down any way you want.
You're not bothering me.
Okay, thanks Axel. Thanks Axel, I appreciate it.
You're welcome. Guys, all the
Maybe
words
he
are
should
still
leave.
on the
Can I
paper.
Can I go now? All right. No.
Making you stay.
I said my one night thing for today.
Yeah.
For the year.
But it's really not bothering me
For
though.
the year, pretty much.
Okay. I'm going to try and limit this a little bit because you're balking today. Let's just say call this example 1 for funsies here. Let's just say my binomial distribution,
You gotta walk a different line.
You know what, my bad, Axel. Maybe I should be.
I was looking for 1, 2,
Yeah?
or 3 successes.
Like me.
1 or 2 or 3 successes.
That makes sense.
Now, on a normal distribution, let's say my mean was 4. And this is a number line down here. Are you okay with the number line?
A number line. What do you have?
Down here. The mean is 4. Let's put 3 here, 2 here, 1 here, 0 here. And you could have 5, 6. Oh, look, a number line. Those are not the standard deviations. And we don't even care about the standard deviations yet. So that's just a number line. Okay, when we did binomial distributions, we couldn't have 1.5 successes. You either had a success or you had a failure. So in the binomial world, x could only take on whole numbers. Do you agree with that? Okay. In the normal world, it's a continuation through the whole number line because we shade everything. Do you agree with that? Okay. So 1 starts here, according to my graph. 3 stops here, according to my graph. But this is a number line. Now think about rounding. Are there any other numbers that would round to 1
Yes.
on this number line? Where are they at?
0.5.
0.5 and up. Do you agree that 0.7 would round to a 1, or 0.8 would round to a 1?
Yeah.
So if we're going to do this in the normal world, I want to include all values that could round to 1 or round to 3. So I've got all the ones that round to 2 for sure. So what I need to do is back up my 1 to include the numbers that would round to 1. And how far back do I go? 0.5, because then at 0.5 and up rounds to 1. So we correct the 1 to make it a 0.5. What numbers up here round to 3? Everything up to and not including
5.
3.5. So I could make the line dotted. It's not going to make a difference in the normal world, but 3.5 is my cutoff under 3.5.
What are we doing?
We're making the correction. So we made 2 corrections. We backed our shaded region up to 0.5, and we're going to stop at 3.5.
What did we say 0.4 though?
Under 3.5. I could go 3.49.
Oh.
And if I was rounding to the...
Isn't included.
Right, I've got it dotted there. So, we would have corrected the 1 to make it 0.5, and we would have corrected the 3 to make it 3.5. Those are called the corrections for continuity. You want to include everything that rounds to your end values. So I just want to practice this skill for a minute.
No, hold on, Carol.
Okay.
That doesn't make sense because you put 0.5 over there because that's including 0.5.
Yep.
So you put 3.5 over there. But,
But I dotted the line. See how I dotted the line here and I kept it solid here?
Oh, okay. There you go. That should have been mentioned.
It's like open circle and filled in circle kind of thing from when you're doing a number line.
Did you just make that up? Or
I did not. That's a rule. Solid lines are included, dotted lines are not. Everything up to it.
The T. You should make like a T over the side.
Okay. So,
This still makes sense.
okay, here we go. Our example 2.
How much space are we talking?
They're just 5 lines.
So is there an answer then for example 1?
No. No, we're going to do it here. Make,
Wait, so is that
See.
an example or?
well, we're going to call it an example because I wrote example 1 there.
Oh my God.
You're trying to make it more complicated than it has to be.
That's the one with that.
I think a little.
My answer or her answer? My answer, I was not sassy.
You never.
Uh-uh.
Let me have a
Well,
fourth
put
grader
it
do
there.
it for you.
It is an example.
Okay. If the probability question said, find the probability that we have between 5 and 10 successes. Oops, I put that in the wrong spot.
Don't worry, Mr. Schwartz, don't worry about it.
All right, between 5 and 10 successes.
Is that a mistake outside the parentheses?
Yep. We're going to make the correction for continuity. So this time you are going to see an answer. So both numbers have to get corrected. We're going to change the 5, and we're going to change the 10.
4.5 and 10.5.
It will be 4.5 and 10.5, but I will make the graph for everybody else that didn't see it quite as quickly. Are you okay with that?
Can we just say?
Wait, why not 10.49?
Okay, so what we're going to write, I don't even care where the 5 and 10 are at. I'm just going to put the 5 here, because I equal 5 and I equal 10. You agree with that? So, I want all numbers that equal 5. Where do the numbers that round to 5 start at?
4.5.
4.5. So I'll make 5 turn into a 4.5. Do I equal 4.5? Yes. Now the 10. Where are the numbers that round to 10?
Why are we just saying that because it rounds?
Yeah, because that's what we have to do. That's the process we have to do.
10.4.
What about 10.48? Less than 10.5. So I should have made that dotted. Let me make it dotted.
Okay, I don't.
Less than 10.5. Because what happens if I equal 10.5? What do I round to? If I equal 10.5,
Then you go to 11.
I round up to 11. Don't give me that look.
But if you equal 4.5.
This is rounding. When did you guys learn how to round? I hate to say maybe 4th grade.
4.5 goes down.
We're rounding to the whole number.
We should just not did trig or stats today.
Okay.
Okay,
Yeah, but you want to go
Yes.
to 10, so it'd be
are we not doing like things on the inside because that
Is
like
that the
off
answer?
limits?
Yep. That's, I would be shading from here to here.
Sure.
But,
No,
Is this the answer?
yes, this is the 2 corrections.
This actually less easier than I anticipated.
why aren't we like?
math.
Can we just move on?
Move on to, I'm going to do a couple more here.
I mean, it's not like why can't it be like 5.4? Cause that.
Because there's still more numbers that round to 5.
So is the solid one always gonna be first?
Let's just do a couple, then we'll see. Let me do 4. Let me do 4. What if I turn it into words first?
No.
Nope, don't do it.
At most, $18 successes. What does at most 18 mean as an inequality?
Less than,
18,
or
less than or equal to 18.
Less than or equal to, that is key. Now we want to make the correction for continuity. I want to change the 18. This number has to get corrected. So think about a number line. Here's 18. Shade to the left, but do I have all the numbers that round to 18 incorporated here? Where are the rest of the numbers that also equal 18?
18.5, so if you go dotted line 18.5.
Dotted line at 18.5.
Oh, I thought we were going the other way.
Less than, but I want everything that includes 18. Watch, let me put a whole bar around 18. How's that? Oh, don't do that? Okay. All right, I won't do it then. I was trying to help. I'm not going to boss. We're just going to go. What?
Question.
Yep.
What? So it said, because in the probability, it says the x is less than or equal to 18.
Yep.
So wouldn't 18.5 be greater than 18?
I've got less than 18.5 though. See how I didn't put the equal to in it? So I never really equal the 0.5. I just get right up close to it. That's why it's a dotted line.
It can't be 18.4 because it says less than or equal to 18.
18.4, rounded to the nearest whole number.
Oh, so rounding to the nearest.
We're rounding to the nearest whole number on all of these.
Okay, makes sense. No,
Okay.
I don't get it associated.
What does 18.4 round to?
18. Okay.
So I've got to go above 18. I can't stop at 18, because there are still more numbers that round to 18.
Can we do more of these?
Right now. Probability that we get
That's stupid because it says at most 18.
more
Just round everything.
than 10 successes.
Okay.
What does more than 10 mean to you?
X needs to be greater than 10.
Greater than 10. So is 10 included?
No.
No. So I want the numbers that round beyond 10. So what am I talking about?
Greater than 10.5.
Okay, so we're going to correct the 10.
X needs to be greater than or equal to 10.5. I think I just did that.
Okay, if that's the number 10. Okay?
I think I'm right.
So what's the correction going to be?
Okay, X is greater than or equal to 10.5.
You would be correct.
Why are we changing signs? I don't get it.
Okay, so if it's not equal to, the answer will,
Actually, isn't that
equal to.
If it's not equal to, the answer will be equal to. You would be correct on that statement. I'm going to say yes.
why a dotted line? Or
I solided it. Okay, I don't want anything that equals 10. Do you see an equal to 10 here? No. So I can't have any numbers that equal 10. Where are the numbers that round, basically saying round to 11 and up? Where do they start at? 10.5 rounds to 11. It's the first number that rounds to 11. So that's why I said greater than or equal to 10.5, because those will go start round to 11 and go up.
Okay. Is there ever going to be situations where they're not enough whole numbers?
Nope.
So it's always just going to be like that.
It's going to be a 0.5 change. Okay, one more. What's the probability of getting exactly 5 successes? Exactly 5. X equals 5. This is the tricky one. Not really tricky, but if this is the number 5, I need to include on the number line all numbers that round to 5. Where do they start at?
4.5
4.5.
and 5.4.
5.5.
So 4.5 is solid, because once I equal 4.5, I round to 5. And then where do I stop rounding to 5 at? 5.5 is dotted. So I would change this to say that 4.5 is less than or equal to X, and then just less than 5.5.
I'm going to get mixed up with the dotted line.
Okay. And I'll tell you, you won't get the probability question wrong, even if you mess these signs up in the middle, because we're still going to be turning both of these numbers into z-scores. I don't care if there's an equal to or a not equal to here. We're still going to turn 5.5 into a z-score. So that is not going to make a difference in the outcome of the entire problem. So even if you mess up the equal to, not equal to, it's all good. Okay, here we go. I want to do 2 problems now. Now we put it all together. Okay.
I love math.
I know.
I use that.
So, the steps. I'm going to give you the steps first, and then we're going to process them. The steps for using normal to approximate binomial
Using normal what?
distribution. And it will tell you in the problems, use the normal distribution to approximate the binomial distribution. That's what's going to tell you to go to this section of your note card, because those exact words are going to be in the problem. Use the normal to approximate the binomial distribution. Then you're going to say, oh God, that's that awful stuff you did on the last day.
Oh,
Okay,
God.
so the first thing you need to do, first, you're going to go back and check to see if the sample size is big enough with this NP and NQ both being greater than or equal to 5. So first, check if NP is greater than or equal to 5 and NQ is greater than or equal to 5. If they are, you keep going on to step 2. Find the mean by calculating n times p. And n times p was actually one of your check things in step 1. And then the standard deviation can be calculated by doing the square root of NPQ. Third step. Third step is to write the probability inequality and then make the correction for continuity, that changing it by a half like we just got done doing. And make the correction for continuity. And then use your NCDF to find the probability. And I'm just going to say NCDF, because you know the steps to doing that. Change your X values into Z-scores, NCDF, and you've got your probability.
It's gotta be awful, isn't it?
Okay, it's not too bad. So here we go. That page is done. All right, first one.
Wait.
Oh, yeah, someone's picking the first one of these. 3. We on 3?
Yeah.
Okay. They did a survey and asked people if they thought that they would see the average person be able to take a trip to the moon. Pay lots of money, but you're going to be able to get on one of those NASA ships and go to the moon.
Shit.
Okay, survey. And they found that 29% believe that you will be, the average person will be able to take a trip to the moon. So 29% say yes to trips to the moon. You're going to randomly select 200 people. Find the probability that at most 65 people say yes. They believe they will see trips to the moon. And then the directions here are: use the normal to approximate the binomial. I don't have to take time to write that. That's how you're going to know to follow this 4-step process. Okay? So, step 1, what are we going to do first?
It's less than or equal to 65.
Okay, we're going to get there in a minute. in a minute. So we need to make sure our sample size of 200 was big enough to make n times p greater than or equal to 5 and n times q greater than or equal to 5. What's my n in this problem? N is 200. My p is the 0.29. So I'm going to first step. 200 times 0.29 equals how much? $5.58? Okay. So is that okay so far?
Yeah.
Yep. Had to be greater than or equal to 5, so we're good. Now we'll check 200 times what? How do I get the Q? Subtract the 29% success rate, so that means 71% failure rate. Is that going to be bigger than 5? I would hope so. It's a bigger percentage. I'm just going to say, okay, I don't even care what it is. I know it's going to be bigger than 5. If you don't, then just go ahead and multiply.
It's 142.
It's 142. Okay?
Wait, why are you putting okay next to it?
Because they have to be bigger than or equal to 5.
And what if they're not?
Then we go back and do the binom PDF and binom CDF. That'll be example 2.
Say like if you have to find the n times q, can't you minus the 58 by 200?
Yes, you can. These two add up to your sample size. That's exactly right. You're on your A game today, Austin. You are. Okay, second step.
It goes away.
I know.
What are we doing on the second step?
Finding the mean.
Find the mean and standard deviation of our now normal distribution. If we want to make the graph here, which I'm going to, because I don't want to have to do it later, I'm just going to make the normal graph right now. I'm going to find the mean.
58.
The mean is 58. That's our n times p. Do you want me to write that out, or are you just good with the 58?
Write it out. You read it.
And that came from 200 times the 0.29. And then the standard deviation we're going to be using later. That's the square root of 200 times the 0.29 times the 0.71. And let's go out 2 places on this. 6.42 if math is correct. Math is correct. Where's my answer here? I didn't write it down. So, I did write it down. Okay. So far, so good on the first 2 steps? Here's the tricky part. Step 3, I think, is probably where if there's any stumbles, it's going to happen here. So, we are looking for the probability of what?
X is less than or equal to 65.
X is less than or equal to 65. Do you agree with that? Everybody else? At most 65. What does it mean to say at most? That's up to and including 65. So the less than or equal to 65. Okay. We wrote the inequality. Now we've got to make that correction for continuity. It's always a half away. It's either going to bump down to 64.5 or it's going to bump up to 65.5. Okay?
With a dotted line.
So here, I'll put it on my graph here. Here's the 65. It's somewhere up here. So we are looking for the probability that X is what? What does the 65 get correct? Because that's 65.
65.5.
So, and do you want me solid or dotted at 65? Dotted. So the 65.5. You always got to change it one way or the other. If it's equal to 65, I've got to include everything that equals 65. So I got to bump it up. Because I've already stated less than. I'm the less than.
So we're trying to find the X? Is that what
Eventually. I just had to fix the 65 to include this part of the number line that's up here. Now I want you to take a look. Even if I had made that solid there, and I put a solid equal to here, I still have 65.5. This is the number that's going to get changed to a z-score. Whether I get this sign right or wrong, it doesn't matter. I won't mark it wrong. If you put, well, 64.5 I'd mark wrong, but you had to know that you went up. But I don't care whether you get this sign in the middle right or wrong. Because 65.5 is now what needs to get turned into a z-score so that we can use our NCDF. So we're on our last step of using NCDF, but what do we got to feed NCDF? NCDF, we need the negative 10 to the 10th. And then I've got to turn 65.5 into a z-score. The mean of my distribution, if I look back at the graph, what's my mean? 58. That standard deviation was 6.42. And what did you come up with for that z-score? I don't know what to tell you.
8, 7.
Point what?
8, 7, 9.
4 steps. That's the whole problem was 4 steps long.
I know, but it's the final answer.
Yep, that's the probability of that sample happening. Okay. Let's just not do the ones that don't pass this first step. How's that? Well, I'll make your life easier there. Okay, so you will just practice the 4 steps today. Let me... Yep, we'll call it good there. I was going to do one more that fails here, and then we do with the binom, but I don't think I want to... I think I just want you to practice this and not get... But I do want you to show this first step. So... let's go with approximating binomial probabilities. Let me make sure 7%. Let's see, randomly select 30 times 7. I gotta make sure these are big enough. That's not. That's good.
It is.
Page 242. I'm going to start on the end here, work my way back to the front. 16.
I'm just gonna wait.
A through C. Yep, I would wait a second here.
I'm too old to you for that.
Yep, just wait a second. A through C. 17. A through C. 18. Nope. 5 through 12 is matching. Okay.
Yeah.
There. What is it? Wednesday?
Yep.
So that's it?
That's it.
I'm just... I came...
I am beside myself.
Oh.
I have my